Hello, everyone. Welcome to the CDM Winter Research Colloquium series. And for our research seminar today, it is my great pleasure to welcome Dr. Debzani Deb, who is an associate professor in the Department of Computer Science and also the founding director of the Center for Applied Data Science at Winston-Salem State University, North Carolina. Dr. Deb received her BS from Shah Jalal University of Science and Technology, MS in Computer Science from University of Adelaide, and PhD also in Computer Science from Montana State University from beautiful Bozeman, Montana, which is also my alma mater. So Dr. Deb and I overlapped for a little bit while I was getting ready to start my PhD program. She was finishing up hers. And it's really good to see you again after all these years. I wish it was in person, but I'll take this for now. Dr. Deb's primary research areas of interest is big data analytics, machine learning, cloud computing, parallel and distributed computing, and computer science education. Dr. Deb leads the iCloud research team at Winston-Salem. She is also significantly involved as co-PI or senior personnel in the following projects: data science in urban studies and sustainability, data science and management research laboratory, NSF IEEE TCPP curriculum initiative, and the mobile response system, MRS. As I mentioned earlier, she is also the founding director of Center for Applied Data Science at Winston-Salem. Very briefly, the center is an institution-wide initiative with the goal of fostering research and education in data-driven knowledge discovery. Lastly, Dr. Deb has over 15 years of experience in higher education as faculty member in 3 different countries: the United States, Australia, and Bangladesh. I'm thrilled to have Dr. Deb at our colloquium to share her research work. The title of her talk is Use of Machine Learning in Touchstroke Authentication and in Exploring Spatial Justice. Welcome again. Thank you for your time to be here, and please take it away.
Thank you, Dr. Ramaraj, for this kind introduction. And then, yeah, I really wish that we could meet in person. It would have been very nice. But again, just like you, I will take it as it is. So thank you again for inviting me for the research seminar presentation. As Dr. Ramaraj said, I'm an associate professor at Winston-Salem State University in the Department of Computer Science, and also the founding director. I have a little bit about me slide. So, I think it's kind of like important to tell why I am here, where I am right now. So I finished my PhD in computer science from Montana State University, but my focus was actually parallel and distributed computing at that time. And my thesis topic was also based on parallel and distributed computing. Then I joined as assistant professor of computer science at Winston-Salem State University at 2011. And then I was doing research, obviously, and teaching classes at the time. And throughout those years, my kind of like research focus shifted toward the Hadoop and Apache Spark system, which are distributed system for big data management. And while I was doing research on those fields, I kind of like grow some interest about the machine learning and data analytics. And then I started to self-taught myself some of the machine learning and data analysis tools and techniques and everything, and started to apply for grants because it is very important to have the funding to kind of like continue doing research in that field. So 2020, I actually received a substantial University of North Carolina Research Opportunities Initiatives funding, and was able to initiate that Center for Applied Data Science at Winston-Salem State University. So previously, when I was doing the assistant professor, and of course I got promoted as associate professor now, I kind of like considered myself to be an educator and researcher. Most of my time was spending on that. But now I feel like most of my time was spending on administrator or collaborating projects, collaborating people, different initiatives, and also doing research as well. So since I am the founding director, and this is kind of like my dream project, so I have to say a few words about the center. So we are a little bit, kind of like every institution has a data science center. Almost every institution, either it is universities funded or externally funded. But we have kind of like a couple of unique goals. Number one is that we are applied data science research center. So not doing foundation research on data science, but applied data science. We have a unique goal. So we are kind of like need-based center. So we are very much focused on our university, our local community, and all the activities, all the initiatives that the center is taking is thinking about the need for the university and community. So therefore, our number one goal is to create a robust ecosystem while involving all the stakeholders from our university and community. And together, we want to work together to make some transformative changes in interdisciplinary research, education, and community outreach. We are also very much interested to study the issues related to the diversity and inclusion of the area of the data science. So a recent survey actually came out and pointed out that data science is severely ill-represented by the female and the minority students in terms of the professional data and data science people. So only 27% of the data analytics professionals are female, and only 3% are African-American, only 6% are Hispanic population. So there is much to achieve on the field of the data science and then promote the professionals in this field. And we are, as an institution, the Winston-Salem State University actually is in a very good position to study the diversity and inclusion issues in the data science because we have a lot of population who are female and student population who are female, and also the minority ethnicity as well. So just, like any other center, as I would say, for the Center for Applied Data Science, we also have outreach activity. We do have educational activity, research activity, some training, seminar, professional development activities as well. And we do have another unique thing, which is called innovation and incubation. So just to kind of like point to the direction that I'm talking about, the uniqueness of our center toward the diversity and inclusion, I would like to point out two things over here. One is our educational initiatives. So unlike every other institution who is mostly focused on having a major in data science or maybe a master's degree in data science or something like that, we also additionally took another major, which is something called an adopter program, where we try to adopt the data science into the social science, humanities courses, science courses, various courses across our university in terms of including a module in the existing courses. So instead of developing additional courses or additional major, which is going to be like, too time consuming or everything, we are actually integrating data science into various curriculum gradually and with some thought. So this is something unique that we are doing. Another thing that we are doing in our center is called innovation and incubation. So we are actually partnering with the small business and local entrepreneur, and we are tying one or two of our skilled student with them to solve their data-driven knowledge discovery problem in their businesses. But at the same time, we are doing something called reverse mentoring. So the goal here for our students definitely is to get some experiential learning experience so that they can actually apply their knowledge in some real life situation. But for the business, our goal is to just motivate them about the data analytics and just to let them know that, this is not going to be one-time business that you just use our center for accomplishing something, but let them realize the importance of data analytics in their various businesses or things like that. So this is something that we are also doing unique or some kind of unique in our center as well. So I'm going to stop talking about the center now and moving with the research talk. Please feel free to stop me if you have any question at any point. I hope that we'll have time at the very end to take the question, but if you have anything that you cannot wait, please feel free to stop me. So I actually choose to showcase two of my research projects for this presentation. One is kind of like a very computer science problem, which is the first one that is you can see in the screen right now. Use of machine learning in touchstroke authentication. So the goal is over here to apply the machine learning to understand the behavioral biometric and which is applied in the smartphone authentication and fraud detection as well. And I have a different project which is going to be showcased in the later part of the presentation. That is kind of like kind of like more showcase the center activity. So that is going to be a center project, but this one is purely a computer science research project. So let's talk about this one. So we are all very much used to with the physical biometric whenever we are authenticating our smartphones or any other devices. So either password system, face recognition, fingerprint recognition, we are very much used to with that. But the problem that this research is focusing on is something called continuous and implicit authentication. So by continuous authentication, it means that once the user is logged in with the physical biometric or some other means with the initial login, how the device is going to continuously authenticate the user. And implicit basically means that the user, that authentication has to be involuntary. That means that user should not be aware about that he needs to do something extra to authenticate himself or herself in the system. For example, during the COVID era, whenever we are trying to authenticate our smartphone, we need to take off our mask off, right? For the fingerprint, we need to put our finger on the device, scanning device or something like that. So these are all voluntary. That means I have to do that with conscious, but implicit authentication would be something that I do not have to do consciously. It will be automatically happening and will automatically being authenticate myself in my devices. So as you can guess, behavioral biometrics such as my mouse activity, how do I do the keystroke movement, like the speed or shortcut, or what kind of advanced key do I use? Those are my unique patterns that can actually authentically identify myself in my device. Similarly, whenever I'm doing the smartphone, so how do I actually interact whenever I am touching the screen? What are my press size? What direction I'm scrolling? What direction I'm flipping my screen? What are the area of my that my thumb or my finger is covering whenever I'm touching the skin? How much pressure I'm putting? So all those things that you can see over here are basically my patterns in my activity or my behavior that can uniquely identify myself in a particular device. So these are very popular, getting very, very much popularity nowadays, behavioral biometric. There are much research has been going on to identify the authenticate user in their devices continuously and implicitly based on the biometric authentication. Here is the paper. If you need more information, then I would like to point you to that one. So we are actually, this research is focused on a particular type of authentication, which is called touchstroke authentication. So that means, all those things that I described in the previous slide, like what is my touch behavior whenever I am interacting with the smartphone, and is that behavior enough to authenticate me in my smartphone? So as you can guess, there could be various features or aspects of this touch behavior. For example, the area the screen is covered by the touch stroke, pressure, speed, velocity, acceleration, and many others as well. Some others are actually over here, listed over here as well. So as you can see, my touch behavior, like which direction, what is the length, what is the pressure, can actually uniquely identify a user onto their smartphone devices as well. So there are, again, much research has already been established research on the touchstroke authentication. There are established model with good accuracy that was able to distinguish an authenticate user such as owner from the attacker or somebody else who does not has actually authentication to use the particular device other than the user. So the goal, the kind of like the problem over here is that whenever we are trying to determine how good or bad those authentication model are, okay, which is based on the touch behavior, we need to actually mimic some other user behavior. So remember, smartphone is a very personal thing. So in my smartphone, there probably won't be any other data beside myself, right? So the machine learning model that we typically build on a certain scenario to authenticate my behavior for my smartphone will only have access to my data, random user data, right? But whenever I'm trying to determine how good or bad that authentication model is, we typically, the most of the prior works or other research actually kind of like randomly choose a couple of more user as attacker and then see how good or bad the model is performing whenever it is trying to distinguish the owner from the random user. However, there is a problem with that. How do we distinguish the attacker from the imposter? Okay, so somebody who is intentionally trying to imitate my behavior or just impersonate the behavior. So who are the imposter? And there are a lot of cybersecurity studies going on which shows that shoulder surfing, smudge attack, even video recording, media recording, all those things are the imposters are actually using deliberately and in a vast scale just to mimic or observe you and learn your behavior and try to do the security breach in your devices. So the problem is that how do we kind of like differentiate the owner from the imposter whenever we do not have the imposter data available? As I mentioned, most of the prior works only generates a couple of other user as a random attacker and then distinguish them, evaluate the model based on those attackers. But how do we generate the imposter data? That's the challenge over here. So whenever we look for the answer for this problem, we actually move to the direction of the GAN networks. So GAN networks are generative adversarial networks, and I'm sure that many of you heard about these networks. These are very, very popular deep neural networks, which are, gaining much success in computer vision and natural language processing fields. So I'm sure that you have seen all those images, which are synthetic image or generated images, which are exactly like the actual images. A couple of years ago, we have a very popular software which is showing the aging face of the people. So that's also the GAN networks, which is kind of like generating what you would look like after a couple of years or something like that. Some of you may also heard about the poem that has been generated, which is very similar to the poem written by Shakespeare and so on. So generative networks are actually getting, as I say, achieved a lot of success in computer vision and natural language processing, but haven't been applied in the situation that we are trying to explore, like, exploring the imposter behavior. Like, can we generate the imposter behavior of a person by using the GAN network? So that's what we kind of like, put our more focus on to explore that question. So whenever we are exploring the generative adversarial network, just to a little bit of, introduction, so how that network actually works. So that actually, the GAN network always have two deep learning network working collaboratively to accomplish something. So one is called generator network, another one is called discriminator. So generator always try to mimic the generate the synthetic data set, which are fake data, not the real data. And discriminator try to discriminate between real or fake data. So that is kind of like the two complementary network working together. And the whole idea is based on a game theory. So it is kind of like generator continuously tries to fool the discriminator. So based on the discriminator, what it is actually saying about the generated data. At the very beginning, generator will be basically generating a bunch of noises, but then based on the discriminator prediction, and using the back propagation, it learns what it should generate to fool the discriminate. That means to make the discriminate accept it is a real data, although it is not actually a real data. So they kind of like, compete with each other, those two networks, and generator continuously get better at generating something which is a synthetic, but almost looks like real data. So whenever we are exploring this, obviously, generating the imposter behavior is one of our major goals. So we want exactly what the generator is doing in original GAN network, which is generate some synthetic or imposter behavior data, which is really close to the real behavior of a user. However, our goal is something additional. So remember, our goal is to distinguish the attack, whether it is coming from an imposter or from a random user as well. So we would like to have an inclusive model, which is going to take care of both of those situations. And we would need our discriminator to be very strong at identifying who are actually what is the class of the data, whether it is an owner or whether it is a something fake or imposter. So those are the two classes of our data. So whenever we are exploring, we came across to this wonderful paper that has been published in 2016 in Auxiliary Classifier Generative Adversarial Network, which is kind of like an improvement over the normal generative network, GAN network that I just explained it over here. So this AC GAN network has an additional task-specific auxiliary classifier. So over here, as you can see, discriminator can only distinguish between real and fake. But in this one, including the real and fake distinction, the discriminator also can say what is the class of that net for the real data or the generated data as well. So the generated data over here is a class condition data, not just random noise, but some class associated with the noise. It generates something that also has a class associated with that. And this is real data. So discriminator, just like previously, trying to distinguish and has two outputs in it. And generator is continuously trying to produce better and better data, which are very close to the real data. So this is the model that we kind of like use to for the experimentation of our research to identify the owner versus imposter or the attacker in our model. So we actually ran our experiments based on a very popular data set, which is called touch analytics datasets. There are 21,000 instances, Touchstroke instances in total available in this data set, and belong to 41 subjects, but which are collected from 4 different Android forms during the various period of time. So how do we analyze the touch behavior? So each of the touch stroke, we actually were able to identify 31 functional features. So again, the pressure, the start, XY coordinates of a touch, the end XY coordinate, the size, area, all those things, and some other features are also being extracted. So altogether 31 features, each of them represent one particular task that belongs to that many touch strokes, belongs to 41 subjects. So the authentication model, we actually have 2 modules, and one is the lightweight process model, which is executed in the smartphone device. And of course, we don't want to use the smartphone device for the training purpose of the model, because training can take, GAN network training can take a lot of time. So we have that other heavyweight process built into the server side. So the way it has been handled is that smartphone device get your touch stroke data, send it to the server for the GAN model training and learning and everything. And then the model prediction behavior has been translated to the smartphone side. And whenever, then it starts to continuously monitor your touch stroke behavior. And if it sends something otherwise, like it is not your touch stroke, then it immediately, notifies or do some action. So that is how the the heavyweight, lightweight, and time constant of the thing has been mentioned. And then, of course, we use the TensorFlow Lite for the lightweight part in the smartphone device, and Python libraries to implement that. So the network, the discriminator and generator that we built in is actually multi-layer perceptron network. So as you can see over here, the generator started with some noise, and that it, ultimately it outputs a synthetic data or fake data, which is exactly the 31 feature vector that we would assume from our real data, whereas discriminator either gets its input from the real data set or the generated data set, and able to identify whether there are 2 outputs of the discriminator. One is whether it is real or fake, which is a binary output. And another one is actually we use a softmax function, the probability output. So two outputs, one for owner and another for attacker. Not going into very much detail about this stuff over here, which could be time consuming, but we'll be happy to take any question at the end if you guys wants to know more. Focusing on the results, right? So what sort of results do we get? So in our data set, as I mentioned, there are 41 of them, but we did not actually incorporate all of them into our model. We only tested 10 of them, and we choose those 10 data set with various size of instances, Touchstroke instances that are available in the data set. So as you can see, subject number 2 has a lot more instances, like a lot more Touchstrokes in our data set, whereas there are other subjects like 4 or 30 who has very small instances. So we kind of like deliberately chose those 10 subject who has various number of instances available in our data set. And then, as I mentioned, so all of the data set, of course, this for subject number 2, that instances belongs to our data set whenever we are trying to authenticate our model based on number 2, subject number ID 2 being the owner and rest of the people are imposter or attacker. So we actually get another 1230 data set randomly chosen from all the other people just to mimic some random user. And then our generated generator in our GAN network, AC GAN network, generated equal amount of synthetic data set. So as you can see, although we initially have only subject number 2 for 1230 data set, but another 1230 data set from all those other instances to mimic the random user behavior, and then similar amount of data set has been added by the generator. So altogether our data set for the subject number 2 for the authentication model become this much. Similarly, for the lowest number of Touchstroke available for the subject number 30, the ultimate data set size becomes only 900 because that's how we created the data set. So as you can see, we are actually just like any other machine learning model, we evaluated our model based on precision recall, F1 and ROC capabilities, and recall shows good kind of like very good recall rate, which is how many of the owner instances the model can predict correctly out of all owner instances. So, for the subject number 2, we are able to get 98% accuracy. On the other hand, have subject number 27, not that much accuracy, or 88% accuracy. But for this kind of authentication model, actually, equal error rate is much more effective evaluation metric. So equal error rate basically means that where the false acceptance rate and false rejection rate of the models are coinciding. So that's kind of like another, if you're not familiar with these terms, all those things I'm talking about, just to imagine that as an error rate, like, how much error the model is producing whenever it is trying to distinguish the owner from the rest of the attacker or just the bunch of random user. So as you can see that, again, for the number 2, we received a very good error rate, only 2%. And then again, for 27, subject number 27, we have substantial error rate over here. But if we take the mean and median, the error rate is somewhat closer to the 7%. So which is comparable to all the other study that has been done in the Touchstroke authentication model. So most of them, the Touchstroke authentication model is covered in the literature, has an equal error rate from something from 2% to 4%. But we have to remember that those models only include one owner and bunch of random user, whereas our model actually has a lot of imposter data, which are very similar to the owner data as well. So considering that fact, we are very happy about our model and what it is performing. So, again, to see how good or bad our AC GAN network is, stable, arrays or robust arrays, we also do the generation loss and classification loss for epochs. So forgot to mention there are 25 epochs that we have gone through. So of course, the discriminator training and test, it started with a very large amount of error because at the very beginning, it was very much scattered all over the place, but ultimately it learns or trained well and then able to predict well as well. This is the generation loss. So generator is continuously doing better and better whenever it is generating the synthetic data set. On the other hand, this is a classification loss, which is, we are also seeing that it is kind of like becoming stable after the 20th epoch, I would say, or something like that. So the conclusion, if we want to, what we want to take out from this research. So again, the results shows that it is possible to get some acceptable authentication accuracies, even if we are challenging our model with a large number of synthetic data, which are closely mimicking the owner data. Our EER performance rates, as we mentioned already, is 2% to 11%, only 7% with the mean. We also notice that whenever we have more data available for a particular owner, the better our model performs. Again, just to show you, whenever we have a very large amount of data set available for the subject number 2, our model performs better than the other subjects whenever there are lesser and lesser data available. What is the future direction? So this is not very old research. As you can see that we started this research, I would say that in 2019. So we are still considering varieties of options. Some of the direction that we are thinking about going is that trying our model with varieties of other data sets. So we only tried it with the touch analytics data set, but there are other biometric data set as well. So we want to try out our model with those data set and see how the model actually perform. Enhancing the AC-GAN model. So we are kind of like still using the basic AC-GAN, which are available in the literature, but can we make any tweak to make it better, to most suitable for our case or serve our purpose better? Another question that we are very interested to address, based on the observation that the more data it is available, the better the model performs. Is there any threshold, like how much data the model should have before it can actually make some sensible performance or authenticate behavior? So how much data there should be available? So we are thinking about exhausting our model with minimal amount of data set and kind of like continuously make more and more data set available to see where does it actually started to get some better performance and so on. So this is the first part of my presentation, which is, as I mentioned, kind of like very much computer science problem and application of the machine learning, in particular deep learning, to solve an authentication problem. The second part of my talk is going to focus on a problem where interdisciplinary research and collaboration is the main aspect. And my research experience on this one is so different than the other one. So basically, whenever I'm collaborating with the computer science colleagues, the experience and the things that I'm doing is so different whenever I'm collaborating with somebody else from some other department. So this research is again application of the machine learning, but exploring something called spatial justice. Okay, so what does it mean by spatial justice? So spatial justice basically means that how good or bad a space is, so how justified a space is. So if you are living in a city, a neighborhood, or maybe the smallest, the unit of our location, which has been in USA, it has been distinguished as a census tract. So how justify or good a particular census tract is. Is it good in depending on a lot of spatial or geographical variables, or it is not? That is the quest that one of my colleague, Dr. Russell Smith from the geography department actually does have. So he has been exploring the spatial justice for quite some years now, but his problem is that he wanna, quantitatively explore the spatial justice. So what does it mean by spatial justice? So there are many research going on. People have been saying this is spatial justice, that is not, but nobody actually quantitative way explore how to measure the spatial justice. So our goal is, of course, how do we can actually understand the spatial justice or space-based variables. And since we do not have any methodology for saying whether a place is a spatial just or unjust yet, because there is no quantitative method to measure the spatial justice yet. So we have to actually take a dependent variable. So we have to kind of like say what actually makes a space good or bad, and see what are the relationship between the space-based variables to that dependent variable. So we choose some fact called economic mobility as our dependent variable. I'm going to talk about that in the next slide. But the overall impact of this research is that if we have a way to say that whether a place is a just or unjust based on different place-based variables, then the planner, policymakers, public officials, activists, sometimes residents will actually have a tool that they can actually, use to fight the spatial injustices. So for example, if they are going to be a settlement about something like a gas station in a neighborhood or something like that, if our model says that having a gas station is not good for becoming a place just or unjust, they can then have a say about that. So this is kind of like the direction that this research is going on. Of course, we are in a very initial phase, and there are a lot more to explore or know about this research. So whenever we are talking about the spatial justice, as I already mentioned, this is still a very theoretical concept, needs to be understood, explored a lot more, but it has a very much big social impact. So, once we have identified this tool, then it has a lot of good implication, what could positively impact different neighborhoods and different societies. On the other hand, what does it mean by economic mobility, and why do we choose that as a measure for saying a place to be just or unjust? So economic mobility is actually a relatively new term that actually been coined by Dr. Chetty at Harvard University, I think in 2015, who actually revealed that where one person is born, so where I'm born and I'm raised, it actually does have a direct causal effect on the probability of my upward mobility. What does it mean by upward mobility? Like, what is the probability that I am going to actually income more rather than my parents at the certain age where my parents and I am in the same age? Like, what is the probability that I'm going to be, advancing to the income ladder more than my parents? So that is the term called upward mobility. And obviously, he showed that Dr. Chetty and Harvard research team showed that where a person has been born and raised, it has a direct causal effect. So just to show you, what does it mean by the economic mobility and how the USA map actually turns out to the economic mobility over there. So as you can see, where I live, which is North Carolina, Charlotte has been mentioned. So I only have, my children probably have only 4.4% chances of reaching the top fifth of the income ladder, starting from the bottom fifth. So if my children, if they are starting from my children, the bottom fifth of the income ladder, they will have only 4% of chance to reach to the top fifth of the ladder, just because they were born in Charlotte. Whereas if they were born in Chicago, where you guys are mostly from, that probability would have been 6.5%. So they have a better chance of kind of like climbing up to the income ladder. Whereas if you're born in San Jose, that is much bigger. So 12.9% of the chance for a person to move up from the bottommost ladder to the topmost ladder, most ladder, which is fifth person, like it goes 20%, something like that. 12.9% of that people has the chances. So this is kind of like, the economic mobility that tells how good or bad a place is. So we decided to use that as our dependent variable and see whether this economic mobility can be characterized by using a lot of spatial or geographical variables. So I see that the time is really short over here, so a little bit going faster over here. So spatial justice, we collected a bunch of spatial variables. In the next slide, you will see them. And then we also build a random forest classifier to see whether those variables can characterize the economic mobility. And then we actually explain the behavior of our model by using a interpretability tool called Shape Tree Explainer method. And then we're able to produce some results. So the spatial features, like place-based features, what are they? So Rocco, who has been doing a lot of research in spatial justice, identified that the spatial justice can be actually referred at different categories like public goods, basic service, cultural goods, economic opportunity, healthy environment. And as you can see, the number of gas stations, for example, whether there is a food desert in that particular census tract, number of schools, water sewer service. So all those place-based factors, these are all collected. And we only ran the study based on our home state, which is North Carolina, because as you can guess, obtaining the data is really hard based on the factors that we are actually looking for. So we actually have 2,157 census tracts across our states, and we collected each and every data that I just showed you in the previous slide based on NC1 map and opportunity insights of Harvard University. For all those place-based variables. So these are our independent features. Our dependent feature is upward unique mobility. However, the opportunity insight actually give us the data, something like the probability of people moving from the lowest ladder to the highest ladder, but we do need something more than that. We kind of like need something like either upward mobility or downward mobility. So we have to do some manufacturing of the data, like, translate the data so that we can kind of like have a binary classification like 0, 1 distinguishing, 0 distinguishing meaning no or downward mobility, and 1 meaning upward mobility. So once we have that and we build our random classifier model, random forest model, we are able to, we actually build 3 models, but we are able to get good accuracy. As you can see, our ROC is actually giving 86% accuracy. So, from a social science perspective, my geography colleagues' perspective, this is a very good model. However, whenever as I mentioned previously, whenever I'm trying to collaborate with a faculty who is non-computer scientist, we as a computer scientist people probably would have been happy with seeing that much accuracy and then focus on other questions like how to improve the model or something like that. However, the colleague that I'm actually collaborating with is not very happy. He doesn't understand what does it mean by accuracy. Like, okay, you are telling me a model that is actually perfecting 86% of the time, but what does this mean? How can I trust this model? Okay, how do I know that the model is behaving correctly? So we have to go a little bit at more research to give him something like that. So this graph is showing the feature importance. So we have in machine learning a lot of feature importance tools. So we use one such tools and was able to figure out that the most important features that are contributing to the model decision are the total jobs, area covered, job density, medical facilities count. And as you can see, if we are talking about the 85% of our model predictability has been actually distinguished by the top 10 feature vectors over here. So the colleague that I'm working with or collaborating with is actually now have much better idea, like why the model is behaving the way it is, and whether the model is trustworthy or explainable enough toward that sense. But then my colleague is again asking this question. So again, just to show how the research actually unfolds differently whenever we are collaborating with a computer science person or a social science person. So then my colleague is asking the question, well, the model has been built. I understand the most influential feature, but what can you tell me about the what are the characteristics of a place that exhibits the upward mobility and spatial justice respectively? Like, how do I know, like, if I increase the gas station, whether it is going to impact us positively or negatively? If we increase the public school, whether it is going to impact a space positively or negatively. How can we find that out? So then we actually have to look a little bit further and came across the Shapely or SHAP tool that I mentioned a little bit earlier, which gives us kind of like the range and distribution of the feature as well, instead of just saying whether they are important or not. So this picture over here is generated by a Shapely tool, which is called Summary Plot. And, just very quickly, this one is giving us some idea like which direction the total jobs, which is a feature, a space-based feature, is impacting our decision. So this positive is upward mobility, that is downward mobility. Blue means the value of the features are lower. Red means the value of the features are, higher. So as you can see, almost certainly you can tell that whenever the red means like total jobs are higher, the values of the total jobs are higher for a particular census tract, the prediction is actually moving toward the upward mobility directions. On the other hand, the area covered having the red on this direction, we can almost certainly tell that the compact area tends to have the upward mobility, whereas if we have a very, very bigger area covered by a census tract, the probability is that it means it can have actually downward or no mobility over there. On the other hand, a couple of other things that is very much noticeable by this Shapely plot over here is that medical facility, food desert, gas station, they all kind of like are detrimental for a space. That means move the prediction of the economic mobility or the spatial justice to downside. That means these are detrimental. On the other hand, if you think about the minimum commute time, which is kind of like a little bit surprising to us, it shows that higher value of the minimum commute time, that means the people who lives farther away from the city, those places are spatially just or have higher mobility than the people who lives in the closer to the city. So there are some very interesting things that my colleague and I was able to identify based on this research. Not only just based on how the model is actually performing, like the accuracy wise, but how we are explaining the behavior of the model, how a specific types of policy or specific set of policy can be actually gathered based on the model behavior. So future work, we have lots of direction that we are still thinking to move this research to. We are thinking about distinguishing between the urban versus rural census tract, because those are kind of like behave very differently. Thinking about adding some additional spatial variables, thinking about using the dependent variable in various injustice. For example, right now we are only our study so far only focusing on the economic injustice, but can we actually also get the spatial factors to be related to the housing injustice, transportation injustice, health injustice, racial injustice? So these are various questions that we are thinking about moving our research to the various directions. So I think that's the end of my slide. This is my contact details, and now I think I'm ready to take any of the questions, if you have any.